So I see right now there are only 20 people. Let's hold a moment of silence for those that failed to come, failed to return from the trip. And here we go. Guys, do you remember there is such a thing called trigonometry? And apparently you're supposed to know it. And assuming that you have, assuming that during this break you spend some time thinking about the sum of angles, of course, Francis, it will obviously be on the exam. We have to know those formulas, guys. Cosine of beta minus alpha is cosine beta, cosine alpha plus sine beta sine alpha. And we have the remaining three formulas that are displayed here. It is ideal if you can derive those formulas. And now we return to calculus. The objective now is to find the derivative of sine of x and of cosine of x. Good? How do we accomplish this? So the derivative of sine x, again, guys, we had two definitions for the derivative. Do you remember the two definitions? We had z and x, and we have x plus h definition. Now, in all algebraic functions, the z and x definition is the more convenient one. But here, just like with exponential maps, the more convenient one is this definition, since here is what you can do. The derivative of sine x, by definition, is h going to 0, sine of x plus h minus sine x over h. Yes? And what do we get? We can use the sine of sum of two angles, x plus h. We expand it, and we get sine x cosine h plus cosine x sine h. We expand this expression, and here is what we have here. Now, if you observe, guys, maybe I should write it on a separate sheet just so that you're not distracted by my further notes here. So again, guys, the derivative, just look at it carefully. The derivative of sine x is limit as h goes to 0 of sine x plus h minus sine x divided by h. Now the sum of two angles formula tells us that we can write it as sine x cosine h plus cosine x sine h. That's the expansion of sine here, minus sine x divided by h. And then what? And then I look at this formula carefully, guys, and I notice that I can take this, where there is a sine x, and I can take this, and I can factor out sine x, right? Sine x here and does not depend on h. And I have this segment where I can factor cosine. So I get limit as h goes to 0. If I just factor out sine from the red, I get sine x cosine h minus 1 divided by h plus, here I factor out cosine, and here I have sine h divided by h. You see? So here is the red part, and here is that blue part. Now, among the things that we're trying to do here, guys, is to teach you to just, you're not in mathematics solving. The answer is 2 or 7. That's completely boring. We're trying to understand what is that telling us. What is that telling us? What is this? And what is this? And I don't mean what the limit is equal to. I mean, what is that limit trying to find? What is the when you're pushed there, what is the end goal? What's the end destination, guys? If you're sitting in an Uber car and somebody calls you and asking you what you're doing, you're not going to say, I am sitting on a sofa inside of a car, most likely, right? You're going to say, I'm driving to Grand Central, right? And if you're in a plane, you might say, I'm on a plane to where? Similarly, where is that limit carrying you? Well, h is getting closer to 0, that's obvious, yes, but what is this expressing? You look at this expression, guys. Do you recognize what is this thing? We did the same thing with e to the x. In taking that limit, what is someone trying to find? Yes, exactly, Humira. Derivative. Derivative where? So this red box, look at it carefully. What is that? Of what form is this red box? Well, it is of the form cosine of 0 plus h. We know that cosine of 0 is 1, so it's minus cosine of 0 divided by h. And what is this thing here? This is the same, but it's really sine of 0 plus h minus sine of 0 divided by h. Do you see what I'm saying? Derivative of cosine and sine at the point 0. So what just happened here, guys? And again, if you understand that we're just watching the same movie again and again and again, what just happened is that we were trying to find the derivative of sine at an arbitrary point. And instead of finding the derivative of sine at an arbitrary point, we were able, we know that they will exist at an arbitrary point. This derivative exists at an arbitrary point as soon as it exists as soon as the derivative of sine exists at 0 and the derivative of cosine exists at 0. Are you with me? Guys, yes? Spring break is out, the sun is out of the ears, you understand. Confirm that you understand, guys. Beautiful. But not just understand, you have to try to think this way, guys. You understand? If you know where you're going, you can get there. This is my point in teaching this subject, of course, right? It's not just even for calculus. I'm trying to hopefully explain to you how you can use that in your thinking. And what you should do is not just try to follow directions. You're not saying turn left or right when you're driving, right? It's much nicer if you know where you're going. If you know where you are going, you can always choose a different route. You are flexible. Do you understand? And you can get to where you are going much better, much faster. Now, here is a question. What do you think will be those derivatives? We will verify what they are rigorously, but what do you imagine those derivatives to be? Right? What's the derivative of cosine at 0 and the derivative of sine at 0? Okay, and for that we can try to guess what it might be by drawing a unit circle. Okay, so here is some circle, and okay, and then what? Then I am going to make my angle very small. Right? Where do the angle is measured in radians, guys? Right? So where do I see the angle? I see the angle right over here. That's the angle H. Agreed? Now here is my sine. And here is my cosine. This is cosine of h, and this is sine of h. What do you think is going to be the ratio of sine h divided by h, where h is very small? Think about it, guys, geometrically, right? You see this h is going to be made, is going to go to 0, correct? Yes, I am pushing that h down to 0. Obviously, what's happening to the red line? The red line goes to 0, and the arc goes to 0. Do you agree? But we are measuring the ratio of the vertical line to the arc. What do you think is that ratio going to approach? Any clue? Okay, so Francis says 1, Zachariah says 0. And let's see what others say. We're talking about sine for a moment, okay? Just about sine. It's not an easy limit at all, by no means. We will talk about it later, but I want you to try to see what it might be approaching. So Tzvi says 1, Francis says 1, Zachariah says 0. And what about the rest of you guys? It's a sort of, you're trying to see with your eye. It's very just, what's your intuition? So a bunch of you begin to say 1. Now, if you say 1, what's the reason you're saying 1? What is that 1 signifying? That 1 means, so Christiana, you say 1 again. A lot of you started saying 1. Now, why are you coming to the consensus of 1? 1 means what, guys? The relationship between the red segment and the blue segment, you think what's happening to them? If they are very, very small, then there is almost what? Almost no difference. How is ratio 1, guys? A ratio is equal to 1 only if numerator and denominator are the same. Do you agree? So if you believe that the ratio is approaching 1, it means that this curved arc looks very much like that straight line. And that, of course, you might not believe me, right? Of course, it's not a good enough argument to say it looks like. We need to have something more rigorous, and we will get there later. But perhaps intuitively, you might suspect what something might equal to, and that helps. Understood? Intuitively, the two curves are going to be the same. By the way, so basically, sine of h over h will approach 1. Notice that h is measured not in degrees, but in radians. As sine h not increases, right? H is this arc, okay? As h decreases to 0, you see that this curve and this red line, they will be more and more of the same length. You understand? Because the curvature, you see, it takes time to curve. You can imagine that the curvature is made. The reason you think this way is a sort of digital thinking. You see, this segment is perpendicular. There is a microscopic segment perpendicular. There is one afterwards like this. So you can think of a circle as a polygon made of tiny segments. And the segment emanating from the x-axis is perpendicular to the x-axis. Do you understand? So in other words, this is the way I try to think of it. You see, if you were to look with a magnifying glass right over here, you would see this is the x-axis, and you would see the blue curve emanating like this at a right angle. So the blue curve and the red curve will then be of essentially the same length. Do you understand? I mean, it's a sort of weird type of thinking, and I'm assuming not everyone is fully convinced, and that's okay. But do you see this type of pixelation? Is that you have this polygon with many edges. In fact, what you are staring at is not a true circle. It is a polygon of many edges. There are pixels there, right? And the pixels that are immediately perpendicular, immediately emanating from the x-axis, are perpendicular to the x-axis. Good. By the way, we have what you call in right now when I stare at the screen that I have here, I have what is called an upper triangular matrix. Okay, so you have a matrix of, I think, 1, 2, 3, 4, 5, 5 by 1, 2, 3, 4, 5, 5 by 5, where over the diagonal I see faces and below the diagonal there are zeros. That's how upper triangular matrix work. You should just look at it. So if you want to change it, turn on the cameras. So good. Do you all see that, guys? Now it's approximately 1. And now a little bit more intuition, guys. Is the actual ratio? What's the actual comparison of the ratio to 1? Is the actual ratio less than 1 or more than 1 or equal to 1? What do you think? The actual ratio, if for let's say for this moment, is the actual what's the actual ratio? Sine h over h. Is it smaller than 1, bigger than 1, or equal to 1? The actual ratio at this moment. Smaller. Very good. You all see that it's smaller. That's brilliant. So so we see basically that sine. We see that sine h over h is actually smaller than 1, and so the limit grows towards 1. That's what's happening. The limit is growing towards 1, at least in the first quadrant. In the second quadrant, sine is negative, but the absolute value grows to 1. To be precise, the absolute value, right? So we don't have to distinguish. Maybe the angle is here. Maybe it's here, right? Maybe h is negative. So the sine h over h grows to 1. Good. Now, what happens with cosine? It's slightly more difficult to understand just by a picture, but I'll try to give you an intuition of what happens to cosine. Good. So now, similar situation. Here is the angle. This is h. This is sine, and this is cosine. Now, you see, guys, that this whole thing is 1. Agreed? This whole thing is 1. Now, what is then? We can then observe what is 1 minus cosine h. 1 minus cosine h. It's this region. Yes, this region is 1 minus cosine h. And now, if I take 1 minus cosine h and divide by h, now what I'm comparing, guys, I'm comparing the length of this segment to h. Okay, and what should it be? Now, how can we figure out what it should be? It's a little bit more difficult. Let's see. Let's use this color. Do you see that I can have this hypotenuse, right? So we have a right triangle and we have this hypotenuse. Now what's happening as h is decreasing? This hypotenuse is going to be more and more the length of h, just like the sine is going to be more and more the side of h. So that means that we know by the Pythagorean theorem, the square of the red segment plus the square of the orange segment is equal to the square of the pink segment. You agree? But do you all see, guys, that the pink segment must be approaching? It's still smaller than h, and if sine is approaching to the same value as h, that means that the pink segment is going to be more and more of the length of the vertical line segment. Yes, and that means that the horizontal orange segment must be going to 0. Do you understand what I'm saying? It's a bit, we can give much better proof of that, but for now, we are just giving you, I'm just giving you a sort of overview. Okay, so this is going to approach 0. Now, the limit we were interested in was cosine h minus 1 over h, which also therefore approaches 0 because it's just minus this, the numerator. It's minus this limit. Notice that cosine h minus 1 is negative. Cosine h minus 1 over h is negative. So at least in the first quadrant, the ratio of cosine h minus 1 divided by h in the first quadrant, it approaches 0 from the negative direction. And actually, the other way to approach, for h to approach 0 is to be in the fourth quadrant, and cosine is still here. So cosine h minus 1 over h, yes, guys, over h is, you see, cosine h minus 1 is negative. This segment is negative here. Good. So this is now what we have concluded. I hope you see it. We have concluded, look at it, this limit is, it looks like the derivative of cosine at 0, and this limit looks like the derivative of sine at 0. And we kind of heuristically see that cosine of h minus 1 over h will approach 0, and sine h over h will approach 1. Which means what? Which means this is 0 times sine plus cosine times 1, which means the derivative of sine is cosine. Write in your notebooks. The derivative of sine is cosine, and a good student will be able to derive it. So for instance, when I was taking such exams, I would always be worried that I don't remember the formula. It's easy to confuse some of them. So I would just derive it very quickly as I began the test, or if I had any doubts. And when you derive it enough times, you kind of see that you can do it very fast. Good. So the derivative of sine of x is equal to cosine x. Okay. Now, what I would like you to try to do, guys, can you do your best, right? I'll give you 6 minutes. Try to use these ideas that I just did for sine to derive find me, please, the derivative of cosine. Okay. And you can use this information if you don't remember the formulas at the moment. Cosine of difference, cosine of sum, you see. So tell me what is the derivative of cosine of x, and actually carry out the definitional derivation. We'll do it in a moment together. Great, Humira. Correct, Christiana. David, wonderful. That's right. All right, let's do it together, guys, and see how fast it should take us. So here, this is this limit. So I want to know what's the derivative of cosine. And for that, I can apply the definition. Good. Now, what is that, guys? So I need cosine of sum of two angles. So this is limit as h goes to 0. And what do we get here? We have here cosine x, cosine h minus sine x, sine h minus cosine x. Okay, guys? Divided by h. And then I see what I can group together. So look at it, cosine x, cosine h minus cosine x, I can group together. Sine came from, you see, you need to know how to expand cosine of x plus h, and we talked about it during the last class. So guys, for this to be a wholesome experience, of course, try to verify all those identities. How do I expand cosine x plus h? It happens to be cosine x, cosine h minus sine x, sine h. And then what you have here is I can take this part and this part together, because here I will be able to factor out cosine. And then there is this remaining part here. And so the limit is what? It's here I can factor out cosine. So it's cosine x, cosine h minus 1. You see I use the red boxes, divided by h. And then here we have minus. And here I can factor out sine x. And here I have sine h divided by h. And what happens here, guys? So I recognize that the red limit goes to what value? Remind me, what is this red limit going to? 0. 0. Guys, you have to draw those pictures and make sure that you see that it's 0 intuitively. That's going to make a big difference. And what is this going to? This is approaching 1. Okay. So what we're left with is it's just minus sine. So the answer is minus sine x. You see, if you understand the sum of two angles formulas, if you understand how to derive them, then it takes just a few moments to figure out this limit, just if you're observing what's happening there. Good. So we now have the derivative of sine and the derivative of cosine. And now you're going to help me figure out the remaining derivatives. What do we do for the remaining functions, right? So we have derivative of sine and the derivative of cosine. Now, will you please tell me what is the derivative of tangent? Figure it out. And you don't always have to go to the definition. That's just a hint, guys. You know the derivative of sine. You know the derivative of cosine. Yes? Now, how can I use that information to figure out the derivative of tangent? Exactly. The rule exactly. And then we will do that. Yes, Jahin, exactly. Okay, Francis, you mean 1 over cosine squared. And then you can simplify that slightly further. Well, what is 1 over cosine, Francis? It's just it has another name. Exactly. Yes, Tzvi, very good. Yes, Humira. Yes, Christiana. Very, very good. All right, so let's now do this together, guys. The derivative of tangent is the derivative of sine over cosine. Yes? And we can apply quotient rule. This main operation here is quotient. So quotient rule, what do we do when we apply quotient rule? We square the denominator. We copy the denominator and multiply by the derivative of sine. And then subtract. And here we take the derivative of cosine times sine. You understand how you can remember the quotient rule? Square the denominator, copy the denominator, derivative of the numerator minus reverse. Good? And of course, guys, even if you forget that, let's say when you become old and gray-haired, you can of course derive it, correct? I mean, you can just remember the stand double ideas, you can remember the definition, and you can derive it in at least 2 ways, I presume. So what do we get here? Cosine times derivative of sine is cosine squared. Do you agree? Derivative of sine, we just verified, is cosine. So that is cosine squared x. Now derivative of cosine is minus sine, and with this extra minus becomes plus sine squared x divided by cosine squared x. Now I know that cosine squared plus sine squared, those are the sides of a right triangle squared, and that gives us 1. And then I just recognize that 1 over cosine squared is secant squared x. We are done. Now please find me the derivative of, we found sine, cosine, tangent. Now please tell me what's the derivative of secant x. Very good, Humira. Wonderful, Zvi. Christiana, great. Yes, Faiza. So then you can, of course, there is a better way to write it. It's absolutely right. But there is a way that makes it easier to remember. And we will show it in a moment. Come on, guys, a few more. You can do it. Here we go. Good, Justin. David, wonderful. So let's see quickly how we take the derivative. It's the derivative of 1 over cosine x. Yes? And what is that? The derivative of 1 over cosine x. It's going to be, we can apply quotient rule. We can say this is cosine squared x. Cosine x times the derivative of 1, which is times 0, minus the derivative of cosine, which is minus sine x, times 1. And what we get is sine x divided by cosine squared x, which we can write as sine x over cosine x times 1 over cosine x, and that gives us tangent x secant x. Now, to remember, it's much easier, it's rhyming better if you say the derivative of secant x is secant x tangent x. You see? Derivative of secant is secant tangent. Easier to remember. Good? Now, the other trig functions are what? So we now have only two remaining, right? So the derivative of cosecant x is going to be minus cosecant x cotangent x, and the derivative of cotangent x is going to be minus cosecant squared x, as you should verify. Good. So we have established several derivatives. We know. Let's just write them on. Just write for yourself. Let's write them all together, guys. First, derivative of sine x is what? Remind me, please. Derivative of sine is very good. Second, the derivative of cosine. So you see, those two can be confusing, right? Derivative of sine is cosine, but derivative of cosine is minus sine. Yes? And then we have third, the derivative of tangent x is secant squared x. Then we have fourth, the derivative of cotangent x is minus cosecant squared x. Then fifth, the derivative of secant x is secant x tangent x. And sixth, the derivative of cosecant x is minus cosecant x cotangent x. Secant and cosecant are very similar functions, just like tangent and cotangent are very similar functions, so it's not too surprising that the derivatives will be very similar. Good? Now let's try to do a few more calculations, right? We review derivatives in general. So derivative of x squared tangent x, please calculate. By the way, remind me, guys, today's class is over at 3:30. Am I right? Yes, good. So go on. And you decided to factor the x, Francis? Okay. Come on, guys. Those are hopefully fast exercises. It's x squared, David. There is some mistake here, maybe a very small one. All right, guys, how do we do that? So the main operation is, of course, product rule, right? So you have here one function f and another function g. And the formula tells us that we do that. Right? So the derivative of x squared is 2x times tangent. The derivative of tangent is secant squared, and then we have this is our result: 2x tangent x plus x squared secant squared. Good. Very nice. Next is what about secant x over 1 plus x squared? What's the derivative? What is completely simplified? Here is a good question, guys. When you will see my exam, or in any exam in general, you don't want to do more or less than what is asked. You see, just read the instructions and do exactly as the instructions tell you. If you find a derivative, you can just stop. You know, we don't care about this particular derivative. We don't really need to have it in any particular form, right? It's only an exercise in checking that we know how derivative rules work. So there is no innate interest in this question. All right. Let's see what happens here, guys. So what we do is we square the denominator. No. So here is, let's say, I will show you how I would have left such a question. So I would have written 1 plus x squared, then 1 plus x squared. Make sure to put parentheses where they're necessary. Derivative of secant is secant x tangent x minus the derivative of the denominator is 2x, and here we have secant x. That's it. We don't need to go and do anything with this function. Good? Now you should be aware, guys, that both the questions on my exam and especially the questions on the final will be conceptual, or at least they will involve some conceptual parts so that it's not easy to just plug it into a computer. Yes, well, you can see the examples I have from the previous semester. You can see reviews, exam 1 reviews, and you can see what the exam was then. But you will see my exam, you will have time to see how I ask questions. It's not too different. Guys, it's very simple. Here is what you should try to do. It's very simple. If you know the material, you can, no matter what exam is asked, if you know the material, you will be able to answer it if you truly understand. Good? It's if you memorize, let's say that in A you have to write 35 and in B you have to write 97, then of course it's easy to be confused. But if you know your landscape, you understand where the roads are leading, and that's what you try to obtain. All right, guys, so here is the derivative, for instance, of e to the x times cosine x is e to the x cosine x minus e to the x sine x, right? This product rule. Guys, would you like to do practice number 1? Do this one. Derivative of x, e to the x tangent x. All right, ready, guys? So this is a triple product. Good. So you just do the same thing, but triple product. So it's e to the x tangent x plus x e to the x tangent x, because here the prime was here, then the prime is here, and finally it is x e to the x secant squared x, because the prime is there. Good. Do you want to do 2 or 3, or you are kind of, you understand the idea and there is no point to it and we can move on quickly? No point. Wonderful. Let's do it. Come on, guys, quickly. Just yes, no, just write y or n so that I move on or stay. All right, well, let's do one more. Which one? Let's do number 2. do number 2 and you know, it gets a, or let's do number 3. Number 3 involves everything, right? Do number 3. Number 3, so this one. Well, that's the question. What do we do first? It should be clear. All right, guys, ready? So you could, of course, use all sorts of things, but what is tangent? Tangent is sine over cosine. So wouldn't it be nicer to simplify it first and say this is just the same as sine divided by e to the x plus 5x squared? You agree that's much easier than to apply quotient and product rule. And from there, you can square the denominator then copy the denominator, take the derivative of sine, which is cosine, subtract, and take the derivative here, which is e to the x plus 10x. Make sure to put parentheses, guys. Especially that the final is graded by a computer. The final is graded by a computer. And then multiply that by sine. By the way, if you had a situation like this, where you take the derivative, let's say, of x e to the x divided by 1 plus sine x, yes? Here, nothing that I can see can be simplified, so what do? You square the denominator, because you see the main operation is division here, so you square the denominator, 1 plus sine x squared, then you write it 1 plus sine x, and then the derivative of the numerator is itself product rule, right? Numerator is product rule, so it's e to the x plus x e to the x, and then minus derivative of the denominator, it's cosine x times x e to the x. Good? All clear? Just in case you're wondering, when you have a combination of product rule and quotient rule, it should be natural to you what comes when. All right, and here, guys, we now begin exploring something very important, and I'll try to explain to you why it's important. So what we just verified that limit as h goes to 0 of sine h divided by h, that equals to 1. And the limit as h goes to 0, by the way, how do I remember those limits? It's because I right away see that they are just definition of derivative of sine at 0, and the second limit is the definition of the derivative of cosine at 0. So it's very easy to remember. And this is 0. Good? Now, what would you say is this? What is limit as h goes to 0 of sine of, let's say, 5h divided by h? What is this? Okay, Humira, good. Good. Now, could anybody explain to me, well, let's say before we explain, let's see what's really happening here. So how do you see right away? The answer is 5, right? There is nothing that has to do with h. It's just what happens here is that if h is going to 0, then the angle inside of sine will become very small, and the angle dividing also becomes small. The pattern that you should observe, guys, is this, is that sine of a small angle divided by a small angle is nearly 1. So what do? I think like this. I think, okay, here is the small angle. Something is missing over here. What's missing over here? What's missing here, guys? Yes, and what number is that, Francis? 5. What's missing here is 5. Do you see why 5, guys? Do not focus on the h. What is the statement? What is limit sine h over h is equal to 1? There is no h really, right? This is just saying if the angle inside of sine is very small and you divide by the angle, you get 1, or you get nearly 1. Do you understand? So notice I never mentioned h. Sine of a small angle divided by a small angle, by that same small angle, is essentially 1. Good? So this is missing a 5, but I cannot just put a 5 here. If I put a 5 here, I need to balance the expression. So it's times 5. Now, what do I get here? I get here that I have here 5 times sine box over box now. And now what is that? This is approaching to 5 times 1, because this ratio here approaches 1. Clear? That's what really happens. That the h is not important. All right, so here it is explained. Now here are a few other examples, guys. So here is sine as h goes to 0 of sine of 6h over 3h. Well, I want the boxes to be 6h here, right? So I factor out the 3, and I see it's 6h over 6h over 6h here. So it's really 6. So it's basically 2 times 1. Good. Sine of h squared. Let's see if you understand that. Tell me, guys, what is the limit as h goes to 0 of sine of h squared divided by h? What is that limit? It's sine of h squared over h, guys. Tell me what's the limit. H is going to 0. Exactly. Christiana, careful. Tzvi, careful. It's h squared. What do you want to do here, guys? So this is, again, do you agree that as h goes to 0, h squared also goes to 0? So this is sine of a box. In that box, I see h squared. I want to divide by the same box. What should be in that box? I have an h here, but I need an h squared. So how do I get an h squared? I multiply by h. But if I multiply by h, I need to multiply that by h. Right? I multiply denominator by h and numerator by h. So that's now h going to 0. And what do we get? We get limit as h goes to 0 of h sine h squared divided by h squared. And what do we get here? We get this part is going to 1. But this part is going to 0. So it's 0 times 1. And the answer is 0. Good? Easy, right? This one, for instance, if I have sine h over h squared on the other hand, then this limit will not exist, because depending on where you go to 0, it's going to be plus minus infinity. 1 over h is approaching to plus minus infinity, depending on h approaching 0 from the positive direction or negative direction, and times 1. Sine of h squared over h squared is 1. So it's not an existing limit. Sine h squared over h does exist. Sine h over h squared does not. And then let's see, maybe one last question, guys. Would you tell me, please, now what is the limit as x goes to infinity? X going to infinity of x times sine of 1 over x. What's the limit? Okay, Zacharias says 0. What about the rest of you? What do you say? Svi says 1, Jet says 1, Christiana says 1. Okay, so 1 over x, okay. So Maria Caria says 1. And you are right, guys. It's good that you see it. What's happening here? Look at it, sine. X going to infinity, that's not important. What's happening inside of sine? It's going to 0. Now I can write multiplication by x can be written as division by 1 over x. So it's the same as sine of 1 over x divided by 1 over x. Right? To multiply by x is to divide by 1 over x. And if you look at it from this point of view, you see what happens? It's sine of something going to 0 divided by something going to 0. It's again that box pattern. Yes? So the answer is 1. It's just the same as, in other words, it's the same in your eyes, should be the same in your eyes as limit when h goes to 0 of sine h over h. Because really what's happening is sine is taking smaller and smaller angles, and we divide by that same small angle. And sine over small angle divided by itself is essentially almost 1. Good? If you look at your calculator, or if you look at the animation I produced on YouTube, you will see exactly the same thing. In other words, what it means is that if you apply sine to an angle that's very small, the sine will essentially not do much. It essentially will be as if it's not there. Good? Because sine of a small angle divided by a small angle is 1, which means sine does not do anything to the small angle. Good? It will, of course, it will make it smaller, right? Because what sine is the red line segment, and the angle is the arc of the circle in radians. So, of course, the angle is bigger than sine, if it's at least in the first quadrant. Good? All right, guys. So we will call it a day. We will call it a day. We will stop the recording unless you have questions or you want to watch a question from What, When, Where. One of the students that I have in another class already has 2 questions that they're going to post. So I'll help them translate it. If you have no questions and you have no desire to watch that, then goodbye.